Hi everyone, I'm Kathy Zitt, Managing Editor of Solar Power World, and I'd like to welcome you to today's webinar, Solar Metal Roofs, Compatibility and Effective Integration. Before we begin, we'll go over just a few house cleaning items. I'd like to mention that this webinar will be available after the presentation on solarpowerworldonline.com. And will also be emailed to all registrants, so you'll be able to view it again at your convenience. Secondly, there'll be a question and answer session at the end of the presentation. This is a great way to pick our presenter's brain, so we encourage you to participate. You can do so by submitting your questions, whatever they come to mind, at any time by typing them into the GoToMeeting panel that's on your right. And lastly, we encourage everyone to tweet about key topics and discuss takeaways using the Twitter hashtag #SolarWebinar. And at this time, I'd like to introduce our presenter. Today, we're thrilled to have Rob Haddock, CEO of S5 Attachment Solutions. So we'd like to extend our thanks to Rob for being here with us today. Included in Rob's background is a long list of credentials: contractor, technical writer, curriculum author, forensic expert, world traveler, inventor, educator, even a rodeo competitor. He is the director of the Metal Roof Advisory Group, performing consulting services for a worldwide clientele since 1989. He is also the inventor and founder of S5 Attachment Technology, now in its 23rd year of business. He holds more than 30 patents and has 42 years of industry experience. He is a course author and adjunct faculty member of the University of Wisconsin College of Engineering. His many technical writings have been published in at least 20 trade journals in 6 languages. In 2012, he was a charter inductee to the Metal Construction Hall of Fame. So we're very excited to have him here with us today to share his expertise. And Rob, you go ahead whenever you're ready.
Thank you, Kathy, and good afternoon to all in attendance. Good morning to those of you out there on the West Coast. I'm going to dispense with the usual joke telling because I can't see if you're laughing or smiling or frowning anyway, and I have a lot of material to cover with you today. Just some of the subtopics that we'll be looking at: the basics of standing seam metal roofing so that you have some understanding of this roof type, then the basics of S5 clamps and the integration with photovoltaic arrays, and then synergies of the marriage of the two. By the way, during this presentation, I will use the word panel within the context of roof panels and module within the context of PV modules. But because that nomenclature panel is used for both, I want to make that differentiation so that you know what I'm talking about. As a general overview, it's important to understand some basics about standing seam metal roofing, and this is especially true of metal because unlike other roof types, metal is part of the structure. It has structural characteristics, making it different from every other type of roofing. Metal can therefore be successfully integrated with solar because it is of itself a mounting platform. And finally, we will also look at a few case studies of the marriage of PV to standing seam metal roofing. The other thing that's important is that, as you will see, metal is perhaps the only roof type that will outlive the solar. So metal really is quite different. But is it a new idea? Well, hardly. This cathedral in Cologne, Germany dates back to the 13th century. And from Notre Dame in Paris to the London Houses of Parliament, to the Dome of the Rock in Jerusalem, and the Royal Palace in Madrid, mosque in Istanbul, metal has been used and coveted for centuries. While most of these old structures were crafted roofs of copper, lead, and even gold leaf, most modern metal roofing in the U.S. today is coated steel. Zinc-coated steel, or galvanized, has been used for more than 100 years, and aluminum-coated for about 50 years. But the most popular coating of today is an alloy of the two, trade-named Galvalume. If you're working on an unpainted steel roof constructed within the last 30 years or so, odds are very good that it's Galvalume coated steel. If it's pre-painted and of the same vintage, the odds are a bit lower, but still very good. The more recent the construction, the greater the odds that the substrate is Galvalume coated steel. The alloy coating thickness on the base steel sheet is very, very thin, about 0.8 mils, or in other words, 8/10,000ths of an inch. Just for a sense of scale, a human hair is about 40/10,000ths of an inch. So it's a very thin coating that protects the base steel from corrosion. There are a few things to know about metallurgy when it comes to any coated steel roofing. One is that the widely published galvanic scale that you see here doesn't always tell the whole truth. While the scale depicts base metals, you should know that any metal forms an oxide layer that may act very differently than its parent metal or its base metal. So the scale can be used as a guide to begin with, but don't be too hasty to draw conclusions based on it alone. Zinc and aluminum get along very well. Copper and any coated steel do not. Stainless, because of its passive behavior, although it appears very low on the galvanic scale, it gets along pretty well with all metals. Notice where graphite is on the scale, very distant from zinc and aluminum. And graphite eats away aluminum oxide layers. Graphite pencil marks on Galvalume will turn red with rust within a few years. Service life. The Galvalume standing seam roof has a service life between 50 and 70 years, depending upon environmental severity. And at a 93.3% recycle rate, steel is the most highly recycled construction material available. Recent industry research substantiates these service life claims with in-field and lab studies of 15 aged roofs from 5 different climate zones all over the continental United States. This roof is projected to have a total of 66 years service life. Others in the study were quite similar. This is true not only of the base material, Galvalume steel, but also of the total roof system, including requisite butyl polymer sealants hidden within the joints and laps. This sealant is behaving as new after 33 years of service. So most aged roofs of this type are still good candidates for solar arrays. The one seen in this slide in southern Germany is 28 years old, yet has a remaining service life of 30 or more years. Standing seam roofs come in many different styles and geometries, some of which are shown here. And this is but a sampling. There are quite a number of available profiles on the market today. Many of these are machine folded using a male and female interlock. Notice the clip that anchors the roof panels to the structure, and then a machine which completes the seam folding, interlocking male and female. Others simply snap together with a male and female interlock. Again, notice the clip that holds the panels to the structure. And a few others are what we call cap seam profiles that use two twin male edges and then a female cap component. Machine folded seams normally use dual component clips for their attachment to the building structure. With this clip type, the top component moves thermally with the roof as it expands and contracts. This roof type is typical to the pre-engineered metal building industry. Most snap-together roof types utilize one-piece clips. With this clip type attachment, the panel rides frictionally on the clip when responding to thermal expansion and contraction. Some residential and light commercial roof profiles are installed over solid decks, while others are capable of spanning over open framing without supporting deck. This is common for commercial and industrial construction. The standard spacing for these structural purlins is 5 feet. Hence, the panel's attachment is also 5 feet. Close examination will usually reveal clip locations from the top side if they need to be known. You can see in this slide the slight bulge along the dotted red line revealing the underlying roof panel attachment clip locations. Standing seam roofs are generally engineered and tested to withstand design wind uplift forces. The testing is specific to the panel's clip attachment spacing, normally 5 feet, but in this case, much closer. The point is that these roofs can be designed to resist almost any uplift load, in this case, 187 pounds plus. The takeaway here is that modern standing seam roofing is quite probably the most durable, serviceable, long-lasting roof on the market today, and the best possible candidate, therefore, for a solar array. Now that we have some basic understanding of metal roofing, let's look at some of the basics of S5 attachments and how they interface metal roofing and PV. I designed the S5 clamp more than 20 years ago. I was a veteran of and a consultant to the metal roofing industry and saw the need to provide a solution for penetration-free attachment of rooftop accessories. It had to be compatible with all types of standing seam roofing, and it has now become the metal roofing industry's standard for the attachment of a host of rooftop ancillaries. So you see, S5 came from the metal roofing industry into the solar industry, not the other way around. That's why it's also recommended by metal roof manufacturers all over the globe and has been successfully used on over 1.5 million roofs. The S5 clamp grips the seam in such a way that it can provide hundreds and even thousands of pounds of holding strength without harming the roof. It's an interlocking mechanical attachment requiring no ballast. And of course, no penetration of the roof panels. No holes, in other words. And on this project, no rails either. Even the ancillaries can and should be attached using the same technology. Combiner boxes. conduits, wire chases, service walkways. Almost anything related to rooftop mounting can be done without intrusion to the roof, preserving all warranties. As we discussed before, standing seam comes in many profile geometries, and still many others not pictured here. And S5 has clamps specifically designed to each of them. S5 is sold with Series 300 stainless mounting hardware and bit tip drivers included. The stainless hardware is metallurgically compatible with any metal roof, but because aluminum clamps are dissimilar to copper, a special brass clamp is also available for use on copper roofs. Notice that S5 only uses special round point set screws. Beware of lookalikes that use cup point set screws. The round point of S5 does not violate the thin, fragile coatings that I spoke of a moment ago, which provide the corrosion protection of steel roofing. And they do not cause fatigue fracture of other soft metals like titanium, zinc, and copper. Unlike a cup point screw, which breaches these coatings, violating warranties and creating a corrosion or fracture site. You can see the slight depression here made by the round point screw that creates a mechanical interlock without breaking the paint or metallic coating. S5 has also done extensive salt fog testing of the attachment to prove no premature corrosion to the roof. While 1,000-hour testing is considered the industry standard, we have doubled that, testing for up to 2,000 hours. And as you can see, even after the Galvalume coating has completely corroded from the salt fog chamber, the clamp and set screws have not caused any corrosion to the roof material. Extensive testing for holding strength takes the guesswork out of any application so that it can be proven to the specifics of any project. And the unique S5 attachment method provides holding strength unequaled by any other product on the market. Here you see the smallest clamp that S5 makes. It's the S5E Mini, and you see here an actual test in failure mode where the panel is beginning to buckle. Notice that the clamp is still holding on, and the failure load in this case was 2,144 pounds, as you see. To find the holding strength for S5 on any panel seam, because remember they're all different, go to the S5 website. On the home page, click on this button below the pretty lady. After clicking OK to the terms of use, this screen will come up. In the solar industry, we're interested most in this load orientation. So click here and our load test table will appear. The table is columnar with a clamp model on the far left, the name of the profile by alpha, its manufacturer alphabetically listed, the name that they call that profile, the gauge thickness of the panel, the screw tension at which the load test was run, then the ultimate failure load, the mode of failure, and in the last column on the right, the allowable load. You will also see the factor of safety in this window, and it can be reset by the user if desired. When relying on these tested values, be sure that the set screws are tensioned adequately. We will talk more about set screw tensioning a bit later. Because I was a contractor by trade, I designed S5 with the installer in mind. That's why the installation is so simple and uses tools that are quite common to the roofing trades. Many are familiar with S5 standing seam clamps, but fewer are a bit less aware that S5 also has innovated prudent solutions for face-attached profiles. These profiles are called by different names that all mean the same thing. Most, if not all, face-fastened profiles have a trapezoidal rib geometry. Hence, they're often called trapezoidal rib panels. While these S5 solutions do penetrate the panels, they also have industry standard sealants pre-applied within the base to simplify installation and ensure weather integrity. The Versa bracket attached through the panel to underlying structure is used for trapezoidal profiles that are face attached and rail-mounted PV arrays. And the Protea bracket is truly universal, fitting trapezoidal profiles of almost any dimension, and it enables attachment anywhere along the panel rib, providing over 500 pounds of ultimate holding strength. Because of the versatility of the L bracket, Protea can be used with top mount rail, side mount rail, or direct attachment with the S5 PV kit. And S5 also has solutions for corrugated profiles. This one attaches through the valley to the underlying structure, and this one through the top crest to either the sheet alone or down through the sheet and into the underlying structure. To avoid jeopardizing roof system integrity, it's important for any roof metal or otherwise that the roof system manufacturer approve the method of interface with his roof system. Every major producer of standing seam in the United States has validated the appropriateness of S5 attachments by their endorsements and recommendation, not only for solar, but also for mounting of any rooftop ancillary, and the list keeps growing. Even the inventor of galvalume coating technology himself has strongly endorsed S5, saying that S5 is the greatest thing to happen to metal roofing since galvalume. And the largest metal coil supplier in the US. And the largest roof system manufacturer in the world. And the largest portable roof panel machine manufacturer in the world. All have endorsed S5 on an exclusive basis. Not to mention the iconic Jiggershaw of Son Edison fame. Aside being the popular choice for rail-mounted systems, S5 has also innovated special hardware for the term we have trademarked direct attach. When using rails, they're mounted transverse to the panel seams with S5 mini clamps, resulting with the modules in the portrait orientation. When using direct attach, the modules would be laid transverse to the seams, resulting with a landscape module orientation. In some cases of rail-mounted systems, an adapter or L-foot is used. This depends upon the design of the particular rail being used. This one has a bolting channel within its base. Tilted racking systems are also mounted with S5 clamps in similar fashion. And in all cases, the mounting is accomplished with zero penetration. While in some cases, rail mounting may minimize or maximize, maximize the space utilization on the roof, a metal roof already has rails of a sort inherent to their profile. So the use of manufactured rails in many cases seems a bit redundant. Direct attachment can be done for as little as 6 cents a watt hardware cost on a large array. With the S5 PV kit, the use of rail is obviated. The following video will illustrate the basics of the PV kit for direct attachment. This video, by the way, is available or can be seen on the S5 website in a more expanded version. Here you're seeing some tools that are required and then also some optional tools. Here you're seeing the end condition. And note as you're viewing this video that the straight and true installation of the first clamp row is critical. You will also notice the use of a spacer tool or jig to facilitate clamp installation. This is simply square tubing with holes pre-drilled corresponding to the module's short dimension. Using the correct tools and procedures makes installation with the S5 PV kit super quick. And the reciprocal, by the way, would also be true. And here you see the installation of a mid-grab condition. S5 PV kit assemblies are also UL 2703 and ETL 1703 approved for electrical bonding. So it's not necessary to interconnect adjacent modules electrically. It's automatic when using the PV kit. All S5 grabs, mid and edge, are universally adjustable, fitting every major module producer's frame dimensions. This is a frequently asked question. Which clamp do I use for my project? And how is the question answered? Well, the answer is below the graphic. Identify the roofing manufacturer, the panel name, and material. How do we do that? Well, there are several ways. The first way, if it's new construction, is to look at the architectural plans and determine who the manufacturer of the roof is. Sometimes that's not possible, or the building is older and the plans are no longer available. In such cases, oftentimes the building owner will know the brand of manufacturer of his roof. Sometimes, of course, he doesn't, or the building may have changed hands. In those cases, if you can give us dimensioned cross-sectional drawings, we can usually identify the profile for you. Here's an example of one such drawing. Even the spelling mistakes have not been corrected here. But a crude drawing like this that's dimensioned will go a long way in helping us to identify for you what the appropriate clamp to use on any given profile is. Another very valuable tool to us is if you can take a photograph of the cross-section of the panel. When taking a photograph, be sure to hold a tape measure up to the seam so that when you email us a photograph, we have some sense of scale, and then we can generally scale the vertical dimension, all the critical dimensions of that seam, and help you to choose a clamp that will fit. And of course, you can always call our toll-free number for this kind of assistance. Once the manufacturer and profile names are known, a quick look at the load table on the S5 website will identify the clamp that's been tested on that profile. So the first point, now we're down to synergies of the marriage, and the first point in a good marriage is not to punch it full of holes. So the obvious synergy, unlike many other roof types, is that you're able to attach to a metal roof without roof penetration. The majority of PV is still done like this on pre-existing membrane roofs. This small job is only 40 roofing squares, 4,000 square feet, 44 kilowatts, and 268 penetrations in the roof. Roof penetrations violate most roof warranties, and in the event of a leak, liability issues often arise. In addition to which, pens in roofing are time-consuming and expensive. Each attachment seen here in this slide costs about $45. An attachment to a standing seam metal roof costs about 1/10 that figure and is done in seconds. The next point is product simplicity. It shouldn't take a rocket scientist, as you have seen. The next point is affordability. Nothing will be used extensively unless it's really cost effective. So here's the advertising claim that says that the installation costs can be as low as 10 cents a watt. But we all know that advertising claims lie, right? Well, here are 3 projects that we will look at in our case studies. But here are also a preview at the mounting hardware costs. These are actual jobs. And installation costs are so low, they're almost as unbelievable. But we'll have a closer look at that in our case studies. Don't be price gouged. There are many gray market, what we call gray market suppliers, who do not honor our recommended resale prices, our MSRPs. S5 therefore publishes its MSRPs online so that you will know what you should be paying. And be sure that you're sourcing S5 from an authorized S5 distributor and not a secondary or gray market. Here the S5U Mini, our most popular clamp, as you can see, sells in quantity of 1,000 pieces for $3.37. And the greater the purchase quantity, the better the price. As you can see here, for the PV kit, a quantity of 600 pieces plus is $5.52. In these quantities, we just looked at a clamp for $3 and change, and now a PV kit for $5 and change. That's under $9 a set. At 2 per module, 2 sets per module, and a 240 watt module, that's a total of less than 7.5 cents per watt. And larger quantities yield even better economies. Of course, smaller ones are a bit more expensive as well. Finally, under synergies of the marriage, let's look at service life compatibility, PV and roof. What's the service life of PV? Now, we all know that the warranted life of most modules produced today is 25 years. But the question here is, what's the service life? It far exceeds the warranted life, perhaps in the 30 to 40 year range, or an average of 35 years. So what is the service life of conventional roof types? I'm referring to typical commercial membrane roofs. An interesting survey was done in 2005 by a very well-known and prestigious consulting firm in the roofing industry. They determined that the service life of various roof types was in almost every case below 20 years. This means that with a 35-year service life on our PV array, we have a roof service life deficit of 15 to 23 years, depending upon the membrane type chosen. In other words, when the roof life expires, we get to dismantle the PV array, tear the roof off, throw it away, re-roof, and then reassemble the PV array. Roof replacement has a huge economic impact. You've got to look at the roof and PV system together as a single asset, and then assess the total cost of ownership over the total life of the whole asset. In contrast, look at the same scenario when using a standing seam metal roof. The service life of the standing seam metal roof is 60 years and greater. The only exception to this would be in severe marine environments where corrosion can be much more severe. So in the case of a standing seam metal roof, there is no roof replacement. The roof outlives the PV system, producing what I call a roof service life surplus of 25 years or more. Now let's look into some case studies. We'll start with a quite large project in New Jersey. This was a Butler MR24 roof by trade name. The modules were BP 200 watt modules, and the total system size was 2.43 megawatts. On this project, the S5 E-Mini was used with a PV kit for direct attachment of the BP modules to the Butler MR24 roof system. Some vital statistics on this slide, but notice that the cost per watt was about 7 cents. This is hardware cost only. We'll look at labor shortly. On this project, attachment was made in 3 locations per module, so using 3 sets per module plus the edge conditions. More typically, modules are attached with only 2 sets plus edge conditions. As I pointed out earlier during the film, on large jobs, a jig is normally made to locate additional clamps upslope from the first row. The dimensioning of the holes in the jig correlates to the module dimension. After proving accuracy of the jig, crews on this job install clamps and S5 PV kits ahead of other crews, which are then placing modules. Using this method, clamp and PV kit installation has been done in under 15 seconds per clamp with a team of 2 men, translating to 120 installations per man-hour. With 3 clamp sets per module, that cost is $1.50 per module. That's using a $60 an hour sell rate. So with 2 clamp sets per module, the cost would be $1 per module. These are labor costs, remember. And at 200 watts per module, these figures translate to less than a penny a watt in labor costs in both cases. Note that this project was done several years ago. With today's module ratings of 250 watts per module, the same cost would be under 6 cents. If attached at 2 sets per module instead of 3, the cost would drop below 4 cents, and these now are hardware costs in addition to the penny a watt of labor. On this particular project, S5 was used for a host of things besides the module mounting, like the attachment of material conveyance walkways, temporary barricades, temporary safety rails, even permanent safety rails, and wire management, both above the seams and below the seams, not to mention even below the modules. Combiner boxes, and in each case, not only preserving the integrity of the roof, but also saving money over other attachment alternatives. There, just for grins, is a quick look at the inverter room of this project. The next project is also in New Jersey. It's the Fort Dix headquarters building in western New Jersey. And it was a Merchant & Evans zip rib roof with 18-inch seam spacing, and the clamp model was the S5Z Mini. This is one of our more expensive clamps at $3.81 MSRP in a 2,500 piece or more quantity, which correlated to this particular project. The modules in this case were sharp 220s, and clamp attachment in this case was done on every second seam, except in the high uplift perimeter zones of the roof where it was done at every seam. You can see here the space loss from the direct attach method, creating a narrow walk space between these banks of modules. We sometimes call this a correction space because the dimension of the module doesn't always jibe exactly with the dimension of the roof panels. Here, on another project, the roof size was enough to leave walk space of about 12 inches between each pair of module rows. This makes it easy to clean or maintain, inspect, or replace modules, as well as the roof itself. In this particular case, it was also a desire of the building owner to be able to access the modules and the roof easily. The next project is a small residential rail-mounted project in California. The S5 U-clamp is by far our most popular and versatile clamp. It will fit about 80% of the standing seam profiles manufactured in North America. And it would fit the double-folded 1-inch standing seam used on this project. Here, the first clamp is being located. Although a hand wrench is being used, an electric gun is advised and is much faster. After the second clamp is located some distance from the first, as you saw in the video, a string line is pulled between the two, and remaining clamps are infilled to complete the first row. In this case, string lines were used for layout of other clamp rows rather than using a jig. Once again, using a jig would be faster, but sometimes string lines are used on smaller jobs like our case study here. Alternatively, a laser could also be used. Even at a third or a fourth the pace of the previous method, that is using a spacer tool, it goes pretty quickly. Notice that the seam height here is only 1 inch. That makes it difficult to get the gun low enough for set screw tightening. But universal knuckle drives, which are available from S5, will facilitate clamp installation on low profile seams like this one. Calibrated wrench tightening is not normally done for each clamp. The usual procedure is to torque check every 50 or 100 clamps to be sure that your gun is delivering consistent and accurate set screw tension. A dial indicating torque wrench is a tool for gun calibration rather than the click wrenches commonly available. These dial indicating torque wrenches are also available from S5. And by the way, we sell these at our cost. We realize the price is a bit dear, and we want to be sure installers are using the right tools. With clamps installed, rails are now attached to the S5 clamps, again using a calibrated gun with a deep well socket. And now, all ready for modules. Note that clamps are installed here on every panel seam to distribute loads uniformly into the roof and structure. Installation of modules for this small system was complete in less than a day, with a clamp cost of $4.40 per watt. Sorry, a clamp cost of 4.4 cents per watt. Of course, you have to add the cost of rail and grabs for apples to apples cost comparison with direct attach methods. I assume that to be in the 15 or 20 range. More recently, on a 4-megawatt rail-mounted project at the Phoenix Sky Harbor Airport, the clamp cost was $2.83 per clamp on a very large quantity. This resulted with cost per watt at 2.4 cents, plus, again, the rail and the grabs. That concludes our presentation, and if I time myself right, we have about 9 minutes left for QA.
Yes, Robert, it's okay if we run a little bit over here because we do have some good questions. But thank you so much for the great insight. Again, we will be asking questions, and remember that you can submit any on the right in your GoToMeeting panel. But we'll start off here with the questions we have. Can you talk a little bit about when microinverters are installed, would rails be needed and considerations with those?
Sure. Most of the commercially available microinverters some years ago required a significant amount of space if they were mounting below the module. Typically, on most metal roofs, the module frame will be 3 to 4 inches above the plane of the roof. The actual glass would be more than that. Today, we're seeing microinverters of much more compact sizes. So a look into the actual dimensions on an actual job, because roof seam heights vary anywhere from 1 inch, that's about the lowest you'll ever encounter, up to 3 and sometimes even 4 inches. So the module mounting is a ½ inch generally or more above that. So you just have to look at the particulars of each job and the clearances required for the inverter. In the event that there's not sufficient room beneath the module for the inverter, then the project may have to be rail mounted.
All right. Thank you very much, Rob. And here's another one. For the S5 standing seam metal roof clamps, do the set screws need to be checked or retorqued over time?
No. We have, in the history of the company, never seen a set screw back out. These are fictitious claims, in some cases aimed by competitive products. But the fact is that S5 has never had a policy or a mandate or a requirement of retightening set screws over time. When the set screw is installed to the correct tension initially, it will never have to be looked at or maintained again for the life of the roof.
All right. Someone else is wondering, Rob, if S5 is considered BIPV because it adheres to the roof.
That's an interesting question. I think the definition of BIPV has kind of been lost. I've watched the definition of building integrated solar change over years of time and from one country to the next as to what does it really mean. In the beginning, it used to mean that rather than have a solar system attached to a roof, that the roof would in essence be the solar system, that the solar system would fulfill both functions at once. I have still not really seen that done successfully, and so I've seen the definition of BIPV change over time. We've had some of these thin film laminates that say, well, our laminate is a BIPV, but that laminate still never replaced the roof. It just stuck to it. So I guess I've got to say that the jury is still out, and the jury is changing all the time on what exactly does that term mean. It is as integrated, in my perspective, it is as integrated as it can be because of the ideal suitability of the metal roof to a module installation. I know that's kind of a wishy-washy answer, but it's the best I can do on that one.
I think that's great. It's a tough question to answer, and hopefully you're getting a second here to grab a sip of water or something, because these questions are definitely coming. If someone else is wondering about with existing metal roof panels, if they're fastened to a plywood deck, how you would verify the correct attachment of the plywood and the metal roof panels to the structure of the deck to resist wind uplift.
I think you'd need an engineer, but somewhere you have to stop. You know, you can call a roof manufacturer and get from him his recommendations of attaching his roof panel to a plywood deck. But when you go beyond that, and now you look at attachment of plywood to trusses, and then, well, why stop there? The load chain doesn't stop there. What about the truss attachment to the walls or to the columns? What about their attachment to the foundation? Somewhere you've got to stop. But for simply verifying adequate attachment of the roof to the wood deck, the roof manufacturer could be consulted for his attachment requirements to standard decks, to OSB decks or plywood decks. To go beyond that, you'd need an engineer to evaluate the entire load chain.
Yeah, a lot of factors in that. Can you use the S5 with any rail on the market, Rob?
Yes. In fact, many rail producers will steer you to S5. We have many advocates in the industry who produce mounting rails and recommend S5 on a regular basis. There are a few rail or rack providers who use some other product, but generally will approve of the use of S5. And as a general rule, roof manufacturers will always recommend S5. And so most rail producers are aware of our products, use our products, endorse our products, even some of those who sell other products as well. But the quick answer was yes.
Got it. All right, I think we can do a couple more questions in here. Rob, are there any issues with corrosion of roof material from the aluminum S5 if you have a corrosive, such as acid rain environment?
This is going to be another slightly wishy-washy answer. The aluminum and stainless components used with S5 are very compatible with any metal used within the metal roofing industry except copper, okay? Now, so that includes aluminum, and it includes galvanized steel, aluminized steel, galvalume steel, titanium zinc, and stainless. Those are the more common ones. For copper, we have a brass clamp. Now, when we talk about metallurgic compatibility, you have to realize that metals form oxide layers, and the oxides may behave differently than the parent metal does. When you're in a highly corrosive environment, like a severe acid rain environment, or worse yet, in a salt environment where the roof components are exposed to constant salt spray, this would be right on an ocean front, for instance. What happens in those environments is that those electrolytes, the acid rain or the salt water, tend to be much more aggressive, and they boil away the metal oxides, so that the parent metal, the corrosion rates are more related now to the parent metal than to the oxide layers. And in some cases, that may mean that they're more corrosive. In other cases, they're not. Copper is a good example, and so is lead or lead tin alloy coatings. So it's a matter of degree, and yes, in acid rain environments, metals will corrode more quickly than in pH neutral environments, but they're still not considered uncompatible. The corrosion rate is related to the aggression of the electrolyte. And so they're still compatible, but you may not have as long a service life as in other examples. For instance, when these surveys that I referenced earlier were done of these 15 roofs in 5 different climate zones, some of those surveys were done in the Ohio River Valley and in extreme acid rain territories. And some others were done in very pH neutral. Well, the life of those roofs in a very acidic environment were found to be in the range of 60 to 65 years. In the more pH neutral content, the expected life of those roofs was approaching 90 years. So it's a relative thing. But stainless and aluminum and zinc are all quite compatible within the context of our discussion here. And the only exception would be in very severe marine environments.
All right, we have, I think we'll do one more question here. Someone's saying, at the beginning of your presentation, Rob, you noted how the roof clips allowed for expansion and contraction of the seamed roof panels. What provision is there for the expansion and contraction of the solar modules in the mounting systems that use your clamps?
Well, the coefficient of expansion for steel roofing is a bit less than it is for aluminum. Now, most module frames are aluminum, and most roofs are steel. So the coefficient of expansion is slightly different. However, the module, whereas the roof panel may be 40 or 50 or 60 or 70 feet long, the module is a small length. Okay, it's not a continuous beam, in other words, like the roof panel is. So the modules are attached, and if you run the math to figure out the amount of thermal movement in a 3.5 foot dimension of an aluminum frame, you'll find it to be extremely negligible. And when you then deduct from that fraction the amount of movement that the roof is actually moving, you will find that it reduces the differential movement still further between the differential movement between the aluminum frame and the steel roof. And that tiny dimension may wind up being 1/16 of an inch or less, which is taken up by the flexure in our mid-grab.
Okay. Well, I think that's all the questions that we have time for today. Rob did an excellent job of answering anything we threw at him, so I'd like to thank him very much. He truly shared his knowledge and his expertise with us. And I learned a lot, and I hope everyone else did too. If we didn't get to your questions, or if you have additional ones, feel free to contact Rob on your own. And again, this webinar will be emailed to all registrants, so you can view it again at your convenience. I'd like to thank Rob again for being here to share his expertise with us. So thank you so much, Rob.
Thank you, and I appreciate all your attendance, and I appreciate you guys for hosting the meeting.
We're happy to share this information with our listeners, and I'd like to thank our audience for listening, and you've had such great questions. Your input definitely makes for a good discussion, so I hope you enjoyed the presentation. And we invite you to join us for more Solar Power World webinars. So thanks again, everyone.
Thanks again, Katie. And Stacy behind the scenes there.